A brief history of pi, from ancient Babylon to supercomputers. Pi. Just two letters, or really one Greek letter, but behind that symbol lies a deep mathematical mystery that has fascinated humanity for over 4,000 years. Pi is as the ratio of a circle's circumference to its diameter. It's a simple idea, and yet the number itself is endlessly complex. It can't be expressed exactly as a fraction, its decimal expansion never ends, and it never repeats. That's what makes pi an irrational number, and also one of the most studied constants in all of mathematics. In this podcast, we will travel back to the beginning. The story of pi starts in the ancient world. Long before we had modern calculators, or even algebra, the Babylonians, around 1900 BCE, had already recognized that the ratio of a circle's circumference to its diameter was always about the same. Their estimate for pi was 3.125. It wasn't exact, but it was surprisingly close for the time. Meanwhile, in ancient Egypt, scribes working on the Rhind mathematical papyrus recorded a slightly better estimate of pi, about 3.1605. They weren't working with formulas as we know them. These were practical people, engineers and builders, estimating curves and arcs with ropes and straight edges. For their needs, it worked. But it was the Greeks who took pi to the next level, and nobody did more for this number than Archimedes of Syracuse. Around 250 BC, Archimedes came up with a clever geometric method to estimate pi more accurately. He began by inscribing and circumscribing polygons around a circle, starting with hexagons and doubling the number of sides. As the polygons grew closer in shape to the circle, he calculated their perimeters to pin down the value of pi. With a 96-sided polygon, he showed that pi was somewhere between 3.1408 and 3.1429. That's remarkably close to the true value we use today, 3.14159, and he did it all without a calculator. Archimedes' method, using geometry to trap pi between upper and lower bounds, was brilliant. It laid the foundation for integral calculus nearly 2,000 years later. And while his approach was grounded in logic and shapes, other cultures around the world were also refining their understanding of pi in their own ways. In China, around 500 CE, a mathematician named Su Chongji used similar polygonal methods and calculated pi to 7 decimal places, 3.1415927. This level of precision wouldn't be surpassed for nearly 1,000 years. At a time when much of Europe was in the so-called Dark Ages, Chinese mathematicians were pushing the boundaries of number theory. India also made enormous contributions. In the 14th century, an Indian mathematician named Madhava of Sangamagrama began using infinite series to approximate pi, centuries before the technique became popular in Europe. He realized that you could estimate pi with a series like 4 minus 4/3 plus 4/5 minus 4/7, and so on. This alternating series, known today as the Gregory-Leibniz series, converges slowly, but it was revolutionary. Madhava's insight opened a new mathematical frontier. Meanwhile, during the Islamic Golden Age, mathematicians like Al-Kashi were calculating pi to 16 decimal places using refined trigonometric methods. They preserved and expanded the knowledge from Greek and Indian sources, often translating key texts into Arabic and passing that wisdom forward through the centuries. By the time of the European Renaissance, pi was back in the spotlight. A German mathematician named Ludolf van Sullen devoted much of his life to calculating pi using Archimedean-style polygons. He pushed it to 35 digits by hand, a stunning achievement in the 16th century. His result was so impressive that the digits were engraved on his tombstone. But the real breakthrough came with the invention of calculus. Isaac Newton, using his newly developed methods of analysis in the 1660s, was able to calculate pi to 15 decimal places. And other mathematicians soon found faster and more efficient ways to estimate the number. John Machin, for example, discovered a formula involving arctangents that allowed him to compute pi to 100 digits with much less effort than polygons required. As the 18th and 19th centuries unfolded, pi became a proving ground for mathematicians. It appeared in trigonometry, probability, statistics, and physics. The number was no longer just a tool for measuring circles. It had become a deep symbol of mathematical inquiry. Then came the computer age. In 1949, one of the first digital computers, ENIAC, was used to calculate pi to over 2,000 digits. It took over 70 hours, but it was a historic moment. Machines had joined the pursuit. In the 1980s and 1990s, two brothers, Gregory and David Chudnovsky, developed a formula based on the work of the Indian mathematician Ramanujan. With their homemade supercomputer, they pushed pi past 1 billion digits. Their work inspired modern techniques still used today. Most recently, in 2022, pi was calculated to more than 100 trillion digits using Google Cloud's computing infrastructure. That's right, trillion with a T. And while we certainly don't need that many digits for practical applications, these computations test the limits of hardware, software, and numerical accuracy. For engineers and computer scientists, pi has become a benchmark for performance. So, what's the point of all this? Why keep calculating more digits? The truth is, most practical uses of pi only require a handful of digits. NASA, for example, uses just 15 decimal places of pi to calculate spacecraft trajectories. That's more than enough to guide probes through millions of miles of space. Even the circumference of the observable universe could be calculated accurately with just 40 digits. But for mathematicians, pi is more than a tool, it's a frontier. Because it's irrational, its decimal expansion goes on forever without repeating. Yet, unlike a random number, pi is completely deterministic. It emerges from a simple geometric relationship. And that's the paradox. A number both mysterious and precise. Order and chaos in one. There's even a fun fact buried in those trillions of digits. Somewhere within the digits of pi, you can find the sequence 1, 2, 3, 4, 5, 6. In fact, you can find any sequence, your phone number, your birthday, or even the complete works of Shakespeare if pi is what mathematicians call a normal number. That is, one where every possible sequence of digits eventually shows up. Whether or not pi is normal remains an open question. So here we are, thousands of years after the Babylonians first scratched numbers into clay tablets, still exploring the depths of this strange and beautiful constant. Pi has traveled through empires, religions, revolutions, and technologies. It's part of architecture, physics, cryptography, and art. And the journey isn't over. Thanks for joining me today on the Math and Physics Learning Channel. If you found this podcast interesting, please give it a like, subscribe for more content, and share it with someone who's curious about math. Until next time, keep asking questions and keep wondering at the infinite world of numbers.